Okay, so now with our approach with these two equation, we have calculated the value of the slope and the value of the intercept. So if we try to plot the graph, put the line in the same graph, so first we need to ask it to hold on, then I have to plot the value of x. So what is the y? That is equals to a0 plus a1 multiplied by the values of x. Okay, if I do it, so this is our, as you can see, so this is the line that you are actually predicting. Okay, so for one I am getting here, this is the actual value and this is the predicted value. For two, this is the actual value, this is the predicted value. So if you think of it like this way, so this was your number of rooms, number of bedrooms in your house. Okay, and this was the price of the house. Okay, from the data that you have, you can have 100 data, 1000 data. From the data you have, you find a graph. You actually made a graph that looks something like this. So this is the graph that you found. But so that means, so for example 1 2 3 4, that means when you have, if you have a house with 2 bedrooms, you're predicting the price should be here, somewhere here. So let's say 20k. But in real scenario, when you go, you may not get the accurate value. You will get somewhere here, maybe 21k, maybe 19k, maybe closer. Sometimes it can be even higher, 22k. But the general distribution, as you can see, normally it follows a normal distribution. So if you take, say for example 1000 record, 1000 data for this value, you will see it will be very very close to this point. Okay, so that is the basic idea of the linear regression, that you are trying to predict something that follows the general distribution, the general trend of the data, not the actual point, not the pinpoint the actual point, but the general distribution. Okay, so I hope the concept is clear to you now. Now one other thing, okay, let me give you one thing about the matrix multiplication. Some of you may have some confusion. Okay, here we had a x that was equals to 1 by 7 vector, right? That was equals to 1 2 3 up to 7. So this is a vector of 1 by 7. This is a matrix of 1 by 7, not a vector. Okay, for y I have another matrix that is 1 by 7. Okay, so it has a value, like what was the value, 0.5, then I have 2.5, okay, something like this up to this. So I have, last to say for example 4. So I have a value x, I have a value y, and I have to calculate the multiplication between x and y. Now from your knowledge of matrix multiplication, you know, if I try to multiply a vector 1 by 7 with respect to vector 1 by 7, can I do it? If you try to multiply, this is not going to work. Why? You know, if it is m by n, okay, this one has to match with the first one. It has to be n by p. This one and this one has to be same. Then the output of the matrix multiplication will be, the size of the output matrix will be m by p. Okay, so when you try to multiply in this way, x multiplied by y in the matrix form, x multiplied by y, so it is actually performing this kind of matrix multiplication. And when you are trying to do it, it is getting that 1 by 7, you are trying to multiply 1 by 7 with 1 by 7. This is not working because the dimension that it does not match. That's why when you come in here, when you saw this thing, it is saying that incorrect dimensions for matrix multiplication. So that's what it means, that this is not the accurate dimension. What you have to do, you have to perform 1 by 7, you have to make it 7 by 1, only then you can perform. Or you can make it 7 by 1 divided multiple by 1 by 7. Okay, let's try the first one. If you do like this way, x multiplied by y prime, what are you getting? You are getting a 1 by 1 matrix, that is 119.5. Is that what you want? That is not what you want. Okay, again, if you try to perform x prime multiplied by y, okay, you are getting a 7 by 7 matrix. That is not also what we desire. Okay. What you want, we want to perform point by point multiplication. Point by point multiplication, that is called element wise multiplication. And when we want to do element wise multiplication, we have to just place a point here, nothing else, very simple. Multiple by y, just place a point here, it will automatically multiply element wise, element by element. Okay, so this is for matrix multiplication. Now as you can see, as like I said, MATLAB is based on matrix multiplication, matrix manipulation. So it is following this matrix multiplication rule. But if you go for NumPy array, the basis is an array, not a matrix. So there, it will not follow the same thing, same procedure. Okay, it will follow a different procedure. It will follow this one is the basic one. Okay, okay, let's leave it there. You don't need to understand. Okay, so one other thing before we finish. As you can see, in one of the previous lecture, I talked about outliers. So when we are actually formulating the idea of this cost function, we are measuring this kind of distance, right? For each of the points, we are measuring this distance. Then we are taking the residuals. Then we are formulating the cost function. Now, say for example, you have a data that is far from here, okay, very high. That was an outlier that we saw. What is the problem with the outlier? Now, if you try to take, as you can see, it will have a very high value of residual, and when you are squaring it, it is going to be very high. So this outlier is going to affect, okay, this line, how this line is placing. So all the points may be very close to it, but only this point, this outlier, this line will be shifted, this line will be shifted towards it. It will make like this because you want to minimize the error, and for this one you are getting the maximum error. So the line will be shifted towards the outlier, and this is going to give you a biased prediction. This is not going to be right. Okay, so what you do, we remove the outlier, we don't take the outlier, we remove the outlier from this consideration, then you will get more accurate version of the curve. Okay, so this is your outlier. Now you may ask the question, how do we find the outlier? There are different ways to find the outlier. Okay, if I come here, let's go back. Why? Okay, let's make it 13.52, let's make it 23.5. okay, let's place it. Okay, so now let's first fold off. I want to go to new graph. Okay, then let's just plot the scatter plot of x comma y. Okay, let's plot it now. As you can see, do I place it? As you can see now, the curve is actually, due to this outlier, we can automatically see that curve is going somewhere in the outside. Okay, so if you try to fit a curve, it will look somewhere there. Okay, so I will ask you to try it by yourself and see why, how the actually curve, how your original curve that you get, how it shifts due to the presence of a single outlier. You follow the same equation, run the same function, and you can see the curve will go a little bit biased. That will not that will not actually represent the trend. Only because of one outlier, the line that we're getting will be shifted towards it, so it is getting biased towards it.